right, this is Algebra Module 3, Topic A, Review, Part 1, Answers. Here we go. Number 1, consider the sequence given by a +8 pattern. So 2 plus 8 is 10, 10 plus 8 is 18, 18 plus 8 is 26. Shay says that the formula for the sequence is f of n equals 8n plus 2. Marcus tells Shay that she's wrong because the formula for the sequence is f of n equals 8n minus 6. And we have to see who's right. So part A, which formula generates the sequence by starting at n equals 1? Well, I'm going to use both. I'll use Shay's first. And that would be f of, let's make n 1. So f of 1 is equal to 8 times 1 plus 2. And if we do that, we get 10. So is the first term a 10? No, the first term is a 2. So Shay's formula does not work for n equals 1. Let's try n equals 0. That's f of 0 equals 8 times 0 plus 2. 8 times 0 is 0. 0 plus 2 is 2. Is that the first term? Yes. So at n equals 1, Shay's formula works at n equals 1. But not n equals 0. So let's check Marcus. Let's see. Marcus for n equals 1 would be f of 1 is equal to 8 times 1 and then minus 6. Well, 8 times 1 is 8, and 8 minus 6 is 2, and that does start the sequence. So Marcus's formula is good if our first term is 0. And we said at the beginning of our unit here that we were going to start all of our first terms at n equals 1, so that there's no confusion. So I'm going to find the 100th term, and since I'd like to find the 100th term, I'm going to use Marcus's formula, because all I have to do is say, what is f of 100, right? If the first term, 1, creates the first number in my sequence, then the 100th term will create the 100th term in the sequence, and I can just plug in 100 for n. So 8 times 100, and then subtract 6. 800 minus 6 is 794. So there's the 100th term. All right. Number 2, write a formula for the sequence of cube numbers. Well, I would make myself a table. I think that's the best way to make sure you understand what's happening. How does n turn into the function of n, or the output? And I would just say my first term is a 1. My second term is an 8. My third term is a 27. My fourth term is a 64. And when I look at this, I say, well, first thing I would do is kind of look and see what kind of pattern I've got going, and I see a +7 and then a +19. So that's not good. My independent variable is changing by 1 every time, and my dependent variable is changing by a different amount each time. So I know this isn't linear, and in fact, they kind of told me what was going on here. They're cube numbers. So I can just say that the output, f of n, is equal to whatever the input is, n cubed. And to check it, I would just say, well, what if I cubed 1? 1 cubed is 1. Yeah, that's right. 2 cubed, that's 8. Yep, that's right. If I look here, 3 cubed, 3 times 3 is 9. 9 times 3 is 27. So there is the formula. Right? This is lesson 3.2. Consider the sequence following a -8 pattern. 9 minus 8 is 1, 1 minus 8 is 7, negative 7, negative 7 minus 8 is negative 15, and write an explicit formula. I'd like to start with the recursive formula because that one is maybe the more obvious one, because if we just take the last term and subtract 8, that's the next term. So I could say f of n plus 1, our next term, is equal to our previous term, current term, minus 8, f of n. So, f of n, no. This would be f of n minus 8. There we go. So the next term is the previous term minus 8, and that's the recursive. But the explicit is different, right? I can't just say, well, if I put a 1 in, the second term wouldn't be 1 minus 8. Right? So I don't get a 9 and then a 1 and then so forth. So I want an explicit formula so that no matter what the number is that I choose, which term number I want, I can calculate the term. So I'm just going to use the table to help me see what's going on, f of n. And my first term is a 9, and my second term is a 1, and my third term is a negative 7, and my fourth term is a negative 15. And I see that there's a change of 1 and a change of negative 8 here. So I know that my coefficient's a negative 8 because it's negative 8 every time. Negative 8, negative 8, negative 8. And my independent variable changes by 1 every time. So I know it's going to be f of n is equal to negative 8 times n. And then I just check it. I just say, well, if I'm looking for the first term, well, the first term should be a 9. And right now, if I put a 1 in for n, I get a negative 8. And that's not what I want. I want it to be a 9. So how can I adjust it? Well, I just add 17. So now when I check the 1, negative 8 times 1 is negative 8, and negative 8 and a positive 17 is a positive 9, and I get the output that I need. And if I checked another, I could say, well, f of 4 is negative 8 times 4 plus 17, and let's see if that's true. Negative 8 times 4 is a negative 32, and a negative 32 and a positive 17 is a negative 15. So it does work, and that is the explicit formula for this sequence. And then finally, I just need to know the 38th term. Well, I just use that explicit formula, and then I just say, well, I want the result out of the 38th term. So f of 38 is equal to negative 8 times 38, and then plus 17. And when you simplify that, you get a negative 287. All right, that's lesson 3-2. Number 2, that was number 1. Here's number 2. Consider the sequence given by the formula a of n plus 1. So the next term is equal to 5 times the current term, and the first term is 2. So what does it mean? Well, I kind of just said it. The next term, this means the next term, a of n plus 1. The next term is equal to 5 times the current term. So this part, a of n, is the current term. Okay, and the first term is going to be a 2. That's going to be a 2. And we're starting with n is greater than or equal to 1. List the first 5 terms. Well, if the first term is a 2, as it says here, and the next term is equal to 5 times the current term, well, 2 times 5 is 10. And the next term is 5 times that, so that's 50. and the next term is 5 times that. That's 250, and the next term is 5 times that, and that's 1250. All right. Lesson 3.3. Write the first 3 terms in the following sequence. Identify them as arithmetic or geometric. Well, then this says the next term is equal to the current term minus 5. So that makes it arithmetic. It's just every new term is 5 less than the previous one. And then I need the first 3 terms. Well, it tells me that the first term is a 9, and 5 less than that would be a 4, and 5 less than that would be a negative 1. So you only needed 3 of those. Okay, the next one, the next term equals half of the current term. Well, this one's geometric because I'm multiplying. If you multiply or divide, it's geometric. If you add or subtract, it's arithmetic. So the first term is a 4, and then half of 4 is 2, and half of 2 is 1. All right, and the last one says the next term is the current term divided by 10. And so this is also geometric. And if I start with a 10, then my next term is 10 divided by 10, which is 1. And the next term is 1 divided by 10, which is 1/10. All right. Number 4, identify each sequence as arithmetic or geometric. And you can see this by what's happening. If you make yourself a table, I would suggest table is probably the best way to make sure on these. And in a testing situation, I would make sure. So the first term is a 14. The second term is a 11. The third term is an 8. The fourth term is a 5. And then I just check it. If my independent variable changes by 1 every time, well, it looks like it does, right? Plus 1, plus 1, plus 1. Then check your dependent variable, and that's a change of a negative 3. And again a negative 3, and again a negative 3. So this looks like it's going to just be subtracting 3 here, and that makes this arithmetic. All right. Part B, did we have to write an explicit formula? We did. Sorry about that. So explicit formula. Well, this negative 3 tells me that that's my coefficient. So f of n equals a negative 3 times n. I know that's the beginning of it. So then I go here and I say, well, 1 times negative 3 is not 14. It's actually negative 3. But I would like it to be 14, so that means I should add 17. And there's my formula. Okay, and obviously linear, y equals mx plus b form. All right, next one, let's look at the table, n, f of n. And let's see, my first term is a 2, my second term is a 10, my third term is a 50, and my fourth term is a 250. And it looks like I've seen this before. Well, it's not just adding the same amount every time, so it's definitely multiplying. It looks like it's multiplying by 5. So I know it's geometric, number 1. And then what's the equation? Well, since it's geometric, I remember that I can say the first term, 2, times the common factor. Well, the common ratio or common factor is I'm multiplying by 5 every time. And if you're not sure what it is, you take the second term divided by the first term. And so 10 divided by 2 is 5. And that will be the same no matter what 2 successive terms you use. If I used 50 over 10, the third over the second, I would still get a common ratio of 5. So the common ratio is 5, and then we raise that to the n minus 1. So geometric sequence, its first term is here. That's first term. And that 5 is the common ratio. Raised to the n minus 1. All right, and I can check it just to be sure. Again, on a test, I would definitely want to check this. So let me check this. 3. This would be f of 3 is equal to 2 times 5 to the 3 minus 1. Well, 5 to the 3 minus 1 means 5 squared. So that's 2 times 25, and 2 times 25 is 50. And that's what I needed it to be. So that equation is a good one right there. All right, last one is the same kind of situation. It's geometric. It's arithmetic, isn't it? It's just we're subtracting 1 every time. So if I use a table, n, f of n, we get the first term is a negative 1/2. The second term is a negative 3/2. The third term is a negative 5/2. So it's changing by negative 2/2, which is a negative 1. So that's going down by a negative 1. Yeah, it's going down by a negative 1 every time. So that's my coefficient. So I'm going to say this is arithmetic, and it's the f of n is equal to negative 1n. And so if I test this, 1 times negative 1n is 1 times negative 1. Negative 1 times 1 is negative 1. I want it to be negative 1/2, so I would have to add 1/2 to make that happen. So my equation is f of n equals negative n plus 1/2. And we can test it to be safe. Let's use this 3. F of 3 is equal to negative 3 plus 1/2. So that means f of 3 would have to be a negative 3, and a positive 1/2 would be a negative 2 1/2, which would be negative 5/2, and my equation works. Okay, so if it's arithmetic, use your table to find your coefficient, and then adjust from there to make the outcome be what you want it to be. And if it's geometric, remember it's this. It's first term times the common ratio raised to the n minus 1. All right, 3-4. This is simple interest and compound interest. So we've got a youth group has a yard sale to raise money for a charity. The group earns $800 but decides to put this money in the bank for a while. Calculate the amount of money the group will have given the following scenario. So first of all, we go to Cool Bank, which is a simple interest rate. And we have to remember that in order to calculate a simple interest rate, we're going to say the value over time is the principal times 1 plus the rate times the time. So we'll need to fill in what information they gave us so we can find out how much money they make, in this case over 3 years. So to do that, I would have, I would say f of 3 is equal to our principal, which was $800, times 1 plus the rate. Well, the rate was 4%, so that as a decimal is 0.04. And we're going to multiply that by the time, which was 3 years. And when you calculate this, it would be 0.04 times 3, first order of operations. Then add 1, then multiply by 800, and our answer would be 896. Okay, and then for the hot bank, it's compounded annually, so compounded interest. And if we're going to find compounded interest, then our formula would be the value, accumulated value over time, is the principal times 1 plus the rate raised to the time, the power of time. So it would look like this. And in order to calculate, we would say, in this case, it's going to be 5 years at 3%. So we're going to fill in what we know. So 5 years, so that's T is a 5. The principal is still $800 times 1 plus the rate, which was 3%, so that's 0.03. And that's raised to time, which was 5 years. So this time we have to, again, follow the order of operations. That's parentheses first, so 1 plus 0.03 is 1.03. Then raise that to the 5th power, and then multiply by 800. And when you do that, the compound interest rate over 5 years is 927.42. 927.42. And then the last question is it better to use the simple interest rate at 4% short term, or is it better to use the compound interest at 3%? And turns out it's the simple interest. The compound interest will overcome the 1% interest in time, but it takes a while. So if you were to fill in for T, if you would say, well, let's look at simple interest at 4% over 10 years versus compound interest at 3% over 10 years, you would see that the simple interest still outperforms the compound. And somewhere beyond that, the compound interest would eventually overtake the 1% advantage that the simple interest earns in this case, but not in the short term. So best short term is simple interest at 4%. Okay, that is the first review. We'll have the second one coming up. Hope that helps. See you next time.